Some real-world or applied problems involve geometry. These situations can cover a variety of problems. One of those are involving the volume of a space. Remember that the volume is measured three-dimensionally, meaning that the unit of measure is to the third power. So like feet cubed or meters cubed or inches cubed. You can just call it cubic meters, cubic feet, cubic inches, stuff like that. So let's look at some examples. A spherical storage tank holds liquid fertilizer and has a diameter of 3 meters. The tank is currently 80% full. How many liters of liquid fertilizer are in the tank if 1 cubic meter equals 1,000 liters? So 1 cubic meter, 1,000 liters. So we know what we're working with here. So first off, you need to know what the volume of a sphere is. Otherwise, you're not going to get very far at all. So volume of a sphere is 4/3 pi r cubed. And all we need to know is the radius of it. That's what r is. And we know the diameter is 3, so if you put in 3 and cube it, you're going to end up with the wrong answer. The diameter is 3, cut it in half to get the radius. So our volume is going to be 4/3 pi times 1.5, because it's half of 3, cubed. You work that out, and you're going to end up with 14.13717 cubic meters. I'm going a little bit further in my approximation. I'm going 5 deep just because I'm going to be dealing with some numbers I don't want to have any rounding error. So I go a little bit further than usual. Now, the tank is currently 80% full. How many liters of liquid fertilizer in the tank? So I need 80% of the max. So I need 80% of this. So I'm going to take my 14.13717 and I'm going to multiply it by 80%. So converting it to a decimal, 0.80, I'm going to end up with 11.309736 cubic meters. Again, I round a little bit deeper just because I don't want to deal with any rounding errors at the end, because you don't want to do all the work and get an answer wrong at the end. More a longer decimal approximation in the middle is usually safest. So that is 80% of the current tank when it's full. And now I'm going to find out how many liters there are. So I'm going to take my 11.309736 cubic meters, and I am going to multiply it by 1 cubic meter is equal to 1,000 liters, so 1,000 liters over 1 cubic meter. So the cubic meters cancel out, and I should have put 1 there. There we go, 1. Cubic meters cancel out, multiply it by 1,000, and we're going to end up with 11,309.7 liters. So I rounded to 1 decimal for this. Again, round to whatever they ask of you. That's all we do. But if you don't know the formula at the beginning, you're going to have a hard time with this. So make sure you know that formula, or any formula that it's asking of you. Next, a rectangular fish tank measures 60 inches by 30 inches with a depth of 24 inches. 1 cubic inch of water holds 0.004329 gallons. It's very little. How much water in gallons is needed to fill the fish tank? So get rid of the next question. That's not for now. So let's just start off with what we know. We have a rectangular fish tank. If we want to know the volume of that, you need the formula, and that is an easier one. Length times width times height. So the volume is going to be 60 times 30 times 24, which is going to end up giving us 43,200 cubic inches. It's not too bad. 1 cubic inch of water holds 0.004329 gallons, so I'm going to immediately convert my volume of cubic inches into gallons. So 43,200 cubic inches using dimensional analysis. Again, I'm going to use my conversion that I know. So 0.004329 gallons over 1 cubic inch. Cubic inches cancel, which is what I want it to do. I do the multiplication because I'm not going to do that by hand. So I put in the calculator and I'm going to round to the nearest gallon, which is 187 gallons. How much water in gallons is needed to fill the fish tank? 187 gallons. Not too bad. Last one. A cone-shaped water fountain has a radius of 50 centimeters and a height of 120 centimeters. How many liters of water are needed to fill the fountain, given that 1 cubic meter equals 1,000 liters? So this one's pretty nice. Should be a little bit familiar. But first off, we're going to start off with a cone-shaped water fountain. Well, it's a cone shape, so we need to know the formula for the volume of a cone. Again, if you do not know this one, you need to. It is 1/3 pi r squared h. Now, I would like to plug in my cubic centimeters, or my centimeters, 50, 120, into r and h respectively, but that would be the mistake. Don't do that, because right here it says given that a cubic meter is equal to 1,000 liters, but I have centimeters. I should convert my centimeters to meters first. So 50 centimeters is going to end up giving me 0.50 meters, and 120 centimeters is going to give me 1.20 meters. Again, just multiply, move the decimal over 2 spots or divide by 100 on both of them. So now that I've converted them to meters, I can actually use my volume formula more accurately. So 1/3 pi times r, which is the 50. The radius is 50 centimeters. 50 centimeters, 0.50. So 0.50 squared. And then the height is 120 centimeters. We know that's 1.2 meters. 1.20. If you drop the 0 from both of them, that's fine. It doesn't make a difference. Plugging that in, running it through, I'm going to end up with 0.3141593 cubic meters. But how much water in liters does it take to fill? So I'm going to take my amount, so 0.3141593 cubic meters, and I'll multiply it by my conversion. So I know I'm going to have 1,000 liters up top and 1 cubic meter in the bottom, because I need to cancel out the unit of measure. And I just multiply across, and I'm going to end up to one decimal place, 314.2 liters to fill this cone-shaped water fountain. So again, just like with the other two problems here, if you don't know the geometric formula, you're not going to be able to solve it. So familiarize yourself with the geometric formula, or at the very least know where you can find the formula itself. But the conversions otherwise are fairly straightforward.